This is May June 2020. Fx equals 2 minus 3 sin 2x, x is 0 to pi, gx is minus 2fx, this one by multiplied by minus 2 in the same domain. Now what we got to do is to just to write down or state the ranges of fx and gx, the range of fx and the range of gx. Easy, quite an easy thing for the children who know the job. So this is in between minus 1 and plus 5. That is enough. Fx is in between minus 1 and plus 5. That is enough for the answer. Gx is in between minus 10 and 2. That is quite enough, right? But now in this particular situation, I should explain you how do I get these answers, right? Now look at this. If you look at sin x, just sin x, it is in between minus 1 and plus 1. This is your knowledge, right? And it is in the domain 0 to 2 pi. But this particular case is 0 to pi, but still what we have is sin 2x. Sin 2x is also in between minus 1 and plus 1 in the interval 0 to pi here, 0 to pi, right? Now look at this. What we have is minus 3 sin 2x here, so we multiply the whole equation by a minus. You know, when an inequality is multiplied by a minus, the inequality is reversed. So minus 3 into minus 1 into minus 3 is 3. This inequality is reversed, minus 3 sin 2x, and this inequality is reversed, minus 3. Now we can kind of rearrange this and write it in this way: minus 3 less than minus 3 sin 2x less than 3. This is just a rearrangement, rewriting of the same step here. Now for the fx, there should be a plus 2 here, so we will add 2 for each and every place here. So plus 2 minus 3, right, plus 2 minus 3 sin 2x plus 2 3, right? And then, and this is minus 1, this is fx, this is 5, minus 1 fx 5, right? So the range of f is minus 1 to 5, minus 1 to 5. If you write down this line here as the answer, that is more than enough, right? What I did here was I showed you how do you get this answer. Now in the next part, you have to find gx range. Gx is minus 2fx. That means you got to multiply this whole thing by minus 2, right? Fx is this, minus 2 into this is here, look at this, inequality is reversed. This is 2, this is minus 10, this is gx. So minus 10 minus 2 fx 2. What I have done here is again rewriting the same thing, right, in the more beautiful manner. So this is gx. So this is another question from May June 2020. There are 3 variant papers, so each and every question I have picked here. Now look at this. There are 2 functions given, f and g. F is x squared minus 4x plus 3, where x is greater than C is a constant. We will see who this C is little later. And then gx is 1 over x plus 1, x is greater than minus 1, right? X is greater than minus 1. Now we got to express fx in the form x minus a squared plus b. This is just simple completing square. Let's take it and see step by step. Fx is squared minus 4x plus 3, and then you take half of this coefficient, that is minus 2, square it, add and subtract. Take half of this minus 2, square it, add and subtract. So when you add and subtract, there is no change in the original equation. These two nullify each other, right? Now we can take these three in a square, right? X minus 2 squared minus, this is minus 4 plus 3. Then our final answer is x minus 2 squared minus 1. X minus 2 squared minus 1, right? So in this case a is equal to 2, b is equal to minus 1. Okay, this a equals 2, b equals minus 1, right? This is a very typical simple question. You don't need much of explanations, right? Now let's see the next part. Given that f is 1 to 1, state the smallest possible value of c. If it is 1 to 1, right, x should be greater than or equal to 2. C is equal to 2, right? C is equal to 2. So this is just one mark. That is also some knowledge that you should have, and you can refer to my quadratic equations videos also for you to get this. It is now given that c is equal to 5. Find an expression for f inverse x. State the domain of f in. This is a trap, right? Now when c is equal to 5, my minimum value will not be minus 1, right? Okay, we will see this. For this part c is equal to 2, fx equals x minus 2 squared minus 1. If x is equal to 5, fx is equal to 5, when you apply it here, fx will be 8. So my minimum value according to this domain restriction is 8. So fx is greater than or equal to 8. In other words, the range of fx is greater than or equal to 8. Remember this, because when we find the domain of this, range of this is the domain of f inverse, right? Look at this. Now you can find the inverse. You take, this is the typical process, y equals this, and then y plus 1 is equal to x minus 2 squared, and then you get x minus 2 is equal to square root of y plus 1, then x is equal to 2 plus square root of this one, because our range of this one should be tally in the domain, right? Therefore 2 plus, because x, this domain is x is greater than 5, so this should be something greater than 5. So if you take minus, it will not be, so we have taken plus here. So f inverse x is equal to 2 plus, and here x is greater than 8. Now usually we take it here as x is greater than or equal to minus 1, but that cannot be taken here. Reason is the domain of the inverse is range of the original. Range of the original is x is greater than or equal to 8. I told you here. If you apply 5 here, it will be 8. So that domain should come, this range should come here as the domain here. Therefore x is greater than or equal to 8. Equality also should be there. Now this is important. This is a trap, because when you see this, if you are a child who has by hearted the thing, you just take x is greater than or equal to -1. But in this case, it depends on the range of this one. Okay, so that is a very important understanding you should have. I told you present day examiners are checking strictly whether you have understood these concepts. Now if you have not understood the concept that domain and range interchanges when you take the inverse, you will blindfoldly give some other answer here, right? Okay, so therefore now when you are studying, refer to all my videos on functions. You will get the concepts very clearly, right? So this is a very important situation. Okay, now we will move on to the next part. What does this say? Find an expression for g(f(x). In the function g, you apply fx, right? We will go on. Fx is this, right, and gx is this. You want g(f(x). In the function g, you apply f, right, and then it is 1 over this, that is 1 over this. Okay, this is g(f(x). g(f(x) is in between 0 and 1 over 9. Okay, right. I hope you enjoyed this video. Then like the video and subscribe my channel, and also press the bell icon so that you can get all my new videos as soon as I upload them.